In general, for GMAT problems, when you're dealing with really little numbers or very large numbers, you'll use a form of scientific notation. And I'm just throwing that out there. There's a key word in this problem. It says, gives the radical, and it says is closest in value. In closest, if they said closest or if they said approximate, what that means is you can mess with your numbers to make them nicer. For example, watch. All right, to start with, this will be equivalent, but let's make this 48. See, 4.8 times a 10 times a 10 to the 8th. 10 times 10 to the 8th will give you 10 to the 9th. But let's take this 10 and multiply it by the 48, by the 4.8, excuse me. And that gives you 48, just moves the decimal one place to the right, times 10 to the 8th. Now 48, think about, we're thinking about square roots. The square root of 48, or 48 is about what? It's about 49, isn't it? So let's switch it. So what's the square root of 49? 7. And the way you simplify a base with an exponent underneath the radical, you take the index, this case is a square root, understood to be a 2, and divide 2 into this exponent. 2 will go into 8 4 times, so you bring out 10 to the 4th. And if there was any left over, like if that had been a 9, if you had the square root, if you had the square root of 10 to the 9th, that would be 2 will go into 9 4 times, and you'd bring out a 10 to the 4th, but you'd have 1 left over, so you'd leave it underneath the radical, but that's not the case with our problem. Now, 7 times 10 to the 4th, this 4 means you're going to move the decimal 4 places to the right. The decimal's there, so 1, 2, 3, 4. So my radical is closest to 70,000, and that is answer B.